Miss, welcome to NMR MCQs with Exam Skills Chem. This is question 1 and this one is about carbon NMR. So when we're looking at carbon NMR, there's a few things you need to make sure you know and it speeds things up for you. But what we're going to do first is just look at this. So how many peaks are there in the carbon 13 NMR of 1,4-dimethylbenzene? So draw your benzene. I'm sure you're sick of drawing hexagons by now, but they're just not going to go away anytime soon. So here's 1,4-dimethylbenzene. What you want to check for to make this really quick for you is there any symmetry? And if there is, what that does, it means that the environments will double up. So our line of symmetry in this one is along the middle, so horizontal. So the top bit looks like the bottom bit. So when we look at this part, we want to identify the environments. So within that section at the top, what you then want to look for is there any branching or symmetry? Okay. So there is a branch. That means this branch isn't like the other 3 carbons, so it's its own environment. This carbon here is another environment because it's attached to the branch and it's attached to the rest of the benzene. But when you look at this molecule vertically, you'll realize that the 2 on the side of the square are the same. So because this is a mirror image and it has symmetry, when you translate that to the bottom part, you will see that the environments are mirrored. So we in turn have 1, 2, and 3 environments. So our answer here is 3. So always look for symmetry, always look for branching. Branching doesn't really apply to this one, but the branch will not be the same as benzene. Right, here's question 2. So this time, how many peaks does a compound have in its carbon-13 spectrum? So just like the last one, still going to be looking at symmetry. Is there any symmetry in this molecule? The answer is no. When there's no symmetry and you have a cyclic compound, that means that every carbon will have a different environment. So we have 1, 2, 3, 4, 5, 6, 7, 8. So the answer here is 8. But what I do get is a lot of students saying to me, oh, but miss, these 2 are the same because they're both CH, they're next to a double bond, and it looks the same. So what you want to do in a cyclic compound is you want to make your way back to the S, because this molecule is not symmetrical because of the S. Okay, so when you make your way back to the S from the bottom carbon, that's the root, or you can take a diversion this way. When you want to go from the top one, that's the root. So you will notice that their roots are not the same. Because they're not the same, that means they're not the same environments. Okay. Question 3. So with this one, don't get caught out. It's in bold, but yet we all miss it. Not. Okay, not support the suggestion. So what we're looking at are 4 things. They've given us 2 are the same, so 2 are NMR, 1 is infrared, and 1 is a calculation, so percentage by mass. What you want to do is process of elimination. Don't go for the easiest one or what you're most familiar with, because chances are it's probably one of the top ones. So first one, so if you are doing HNMR, this says it has 3 peaks, and the integration ratio is 2, 3, 3. So peaks is environments, just like carbon NMR, and integration ratio means number of hydrogen, okay, in that particular environment. So what we want to look at is if you struggle with working out the environments for carbon NMR, I mean hydrogen NMR, what you want to look at is you want to look at the H's or the CH's and you write N. So N is the neighbour. What is the neighbour to this CH3? The neighbour is C double bond O. Okay. Then do the same thing for the next one. So when you look at these 2 H's, the neighbour is CH3 on one side, and on the other side, the neighbour is O. Okay. When you look at these 3, the neighbour is CH2. So when you look at the neighbours for all of them, none of the neighbours are the same. That means all 3 hydrogens are in different environments. So it does have 3 peaks. Okay. Then the integration value is 2, 3, 3. So when you look at them, the first one on the left has 3 hydrogen in it, so that's 3. The second one on the right, so CH2 has 2 hydrogen in it, and the other one has 3 hydrogen in it as well. So that means that is correct. So that can't be the answer because remember it says not. So your next one is looking at carbon NMR. Just like I said in the last 2, if there is symmetry, then every single carbon will not be the same. will not be different. If there is symmetry, then they will be the same. So in this case, this is not a symmetrical molecule. Because it's not a symmetrical molecule, we are going to have 1, 2, 3, 4 carbon NMR peaks, because there is no symmetry. Okay, and this is how you want to look at these things. So now we know that, and we don't even have to look at the other two, so we're not time wasting. Right, next one. Right, so this one says how many peaks will be observed in the low resolution proton NMR. Low resolution just means there's going to be no splitting patterns. Okay, so no singlets, no triplets, no doublets. Okay, that's all it means, so don't get thrown off by it. So it's a let me just write pattern. So you got proton NMR. So either draw this or you can visualize it. It depends on what stage you're at. I'm always going to draw it. So when you're drawing, if you get stuck with drawing, to start with the ones here. So I'm going to do the CH first. Attached to this first CH is 2 CH3s, so I'm going to put those on. Okay, then go back to it. So I've done that one and I've done that one. And now I've got COO. So that's going to be my ester. And then I've got 3 CH2s in brackets. Now most people get confused and think they're branches and they don't know what to draw, but it's just, they're just writing it the lazy way. So you've got CH2, CH2, CH2. You can't have branches of CH2, so that's why it's not a branch. Okay, and then at the end we've got CH3. Okay, so you can draw it mixed because no one's going to tell you off for not having it displayed or structural, so you do how you need to do in these ones. So when you look at this, we want to look at environments. It's the same thing. Has it got 4, 5, 6 or 7? So look at the neighbours, right? So I'm going to focus on the first one. So you've got CH3. The neighbour is CH, so this one here. This CH3 has the same neighbour, so therefore these are the same environment. Okay. When you go to the next one, so this one, the neighbour is CH3, okay? When you go to the next one, your neighbour for these two is CH2 on one side, and your neighbour on the other side is just an O, okay? Then go to the next two, and your neighbour for these is CH2 on one side, and CH2 on the other side. Okay, then go for your next one. So your next CH2, your neighbour is CH3 and CH2. Okay, and then the last one, you've got this one, your neighbour is CH2. Now when you look at all the neighbours, none of the neighbours are the same. So apart from the 2 CH3s which are on the same carbon, none of them are the same. So we've got 1, 2, 3, 4, 5, 6 environments. So our answer is C. Okay, next one. So with this one, we are looking for which one does not. Remember, that does catch people out. Don't let it catch you out. So it does not have a singlet peak on its proton NMR. So proton NMR, what you will notice is all of these are esters because they end in O8. So what I'm going to do is just draw the ester bond. Okay, and if I want a singlet on the methanoate side, this side is the side bonded to the C double bond O. So if I have methanoate, I have 1H. That's a singlet. Okay. If I have ethanoate on that side, I'm going to have this. So CH3CO. That's a singlet. Because its neighbour is CO, it has no hydrogens. Okay. So a singlet peak means the neighbour has 0 hydrogens. So that's true for those two. So it's not those two. Okay, so they have singlets. Now go to your next one. So now we have propanoate. If I extend this chain any further than 2 carbons, I end up with 2 neighbouring hydrogen environments. So I've got a CH2, CH3. This is not a singlet. So now we found it. Okay. That is our answer. But what you could do is you could draw the other side as well. Okay, so if you have a methyl on the other side, that's a singlet. Anything more than one carbon on the other side would not give you a singlet. Okay, so just make sure you know how to draw your esters. Okay, next one. So you will see all of these require you to know your functional groups. So which amine has only 3 peaks? 3 peaks in its proton NMR. Okay, so we're going to have to draw these unless you can figure it out in your head. If you can visualize, that is wonderful. So an amine group is, remember, RNH2. Okay, these are different types of amines. So you get primary, secondary, tertiary amines and quaternary salts, but we're just going to draw them out. So we've got methylamine, so we've got NH2, and then we've got a CH3. Right, when we look at this, the 2 H's on the N are going to be the same environment because they're bonded to the N. And these 3 are going to be a different environment. So this one has 2 peaks. Okay, when you look at trimethylamine, okay, the name should give it away, but sometimes we need to draw it out. So I'm just going to draw it out. We've got trimethyl, so 3 methyls on our amine. Okay, this is a tertiary amine. So if we've got 3 of the same group attached to the same atom, that is 1 peak. They are all in the same environment. Okay, so next one is diethylamine. So we have diethyl, so I've got a CH2, CH3 and a CH2, CH3 and 1H. So there's a bit of symmetry in this one. So because there's a bit of symmetry, it is going to cut down the number of environments. So we've got 1 H on the N, which isn't like the rest of them. We've got CH2, so the neighbour to this one is the CH3 and the NH. Okay, and then we have the CH3. Okay, and because the other side, the left side, is the same, we're going to have the same environments repeating themselves in the ethyl group. So this one has 1, 2, 3. So our answer here is 3, so C. Okay, and then propylamine, if you wanted to draw that, you can draw that. So just for the sake of doing it, you've got propyl, so CH2, CH2, CH3, and then you've got your 2 hydrogens. So you've got your hydrogens on your N in the same. You've got CH2 here. The neighbour to this is a CH2. You've got a CH2 here. The neighbour to this is the CH2 and the CH3. And then you've got this one on the end whose neighbour is CH2. So here we've got 1, 2, 3, 4 peaks. Okay, multiple choices are a great way to just brush up on this sort of stuff. Okie dokie, next one. So propene reacts with hydrogen bromide to form a mixture of saturated organic products. That first line requires you to know a mechanism and understand what is going on in this reaction. So this is one of the harder ones if you are not sure, if you're not good at layered questions. So first you have to know what happens in the reaction between propene and hydrogen bromide. So I suggest you either draw it out or you just know it, it's your choice. Depends on where you're at in the course. So you got HBr. Okay, so in this reaction, what's going to happen is you've got electrophilic addition. And during this electrophilic addition, because propene is not symmetrical, it will form a minor or a major product. Okay, so minor is a primary carbocation and major forms a secondary carbocation. So when that double bond breaks, this H can add itself to the first carbon or the second carbon. So if it adds itself to the second carbon, we get the minor. Okay, like that. So we end up getting the bromine coming along, or the bromide, coming along to attack a primary carbocation, whereas in the major one, that all happens in the middle. And the reason for this is that it's more of a stable structure. Okay, so that's what happens there. So when we read on, you have to think of this in your head, or you need to draw it out. Okay, drawing it out obviously takes time, so the more fluent you are, the better this will be for you. And then the next part says the proton NMR spectrum of the major, so we only care about the major. So our major product is 2-bromopropane. Okay, so I'm just going to redraw it over here. So we've got 2-bromopropane, and then it says has. Okay, so I wouldn't even look at these until you figured it out. Because it's proton NMR, the first thing you want to do is figure out the peaks. Is it going to be 3 or is it going to be 2? So when we look at this, we've got 1 hydrogen here in the middle, and then it's kind of symmetrical around that CHBr carbon. So this is one environment, and the CH3 on the other side is the same environment because both of them are connected to that same carbon. So this only has 2 peaks. Okay, so 2 environments, 2 peaks. So automatically we cross off A and C, and then we have to decide is it B or D. So when we look at relative intensities, the relative intensities is the number of hydrogen. Okay, so when we look at the circles have 6. Okay, and the square is 1. So our answer is D. Okie dokie, still here? This is the last one. So which one of the following has a singlet peak? Favourite question in proton NMR. So again, look at the mix of things that we have here. So we have 2 esters. So we're going to have to draw our ester bond out, maybe. We have a ketone and we have a halogen alkane. So with the last 2, automatically they have long chains. So if they have long chains, that means that you're going to get CH2s and CH3s next to each other. So that means you're not going to get a singlet peak. It's not possible. Okay. So when you go to the A and B, which is your esters, it is possible, but we have to do what we did in the other question. So we look at ethyl propanoate. So propanoate means you're going to have 3 on this side. If you've got 3 carbons on the double bond side, you've got that coupling of CH2, CH3. That means no singlet. Okay. And then ethyl, we'll try on the other side, so that we've got 2 carbons on this side. So again, we've got a CH2, CH3, so there's no singlet. So the answer, just by elimination, is propyl methanoate. But if you want to draw it, you will see propyl does not, the propyl part, sorry, that was wrong. Propyl does not have a singlet, but methanoate does, because it's just 1 carbon and a hydrogen. That's the singlet. And then on the other side, that's where your propyl is. Thanks for watching NMR MCQs with Exam Skills Chem. And if you enjoyed that and you found that useful, don't forget to like, follow and share. And if you want to, leave me a comment for your pain topic and I'll do that next.